Welcome to Properties, Methods, and Structs. To help review, here we see a relatively sophisticated version of the ball class. It has 5 attributes representing the ball's texture, position, velocity, speed, and the sprite batch to draw the ball to. We then see 3 accessors that will allow the Game 1 class or paddle class to access the ball's position, velocity, and texture. Notice that we don't have any set methods for these attributes. That's because we don't want any outside class altering these values directly. They must use the reflect method below. We then see the constructor for a ball. Notice that it has no return value and a parameter for each attribute. This is good coding practice, as the constructor should initialize every attribute in the class. Finally, we see 3 facilitators that help the ball accomplish more exciting things. A reflect method that requires the normal vector. The reflect method will then reflect the ball's velocity around that normal vector. There's an update method that will run every frame and move our ball a little, and a draw method that will simply draw the ball at its current position. Notice that the update method will change the position by multiplying it by the time since the last frame, its velocity, and its speed. Speed in this way is represented as pixels per second. Here we see the Game 1 code that will create, update, and draw the ball correctly. Much of the code in Game 1 has been amended to fit it on a slide. So don't just copy-paste this into your code and expect it to work. First, we create an attribute in Game 1 to represent the ball. Since Game 1 is a class, we make this attribute private, since we wouldn't want outside classes to arbitrarily modify the ball. The Game 1 class should control all access to this ball object as it governs the game. Then, in the load content method, we create the actual ball object. We give it a sprite batch, texture, position, velocity, and speed, which represent the number of pixels to move per second. In the update method, we call the ball's update method, which will move it to its new position. Then we bounce the ball off the top and bottom walls. I've omitted the paddle interactions for simplicity. Finally, in the draw method, we draw the ball by calling its draw method. The benefit of using a class is that when we want to add a second ball or a second paddle, we won't have to rewrite as much of the code in Game 1, just a few lines. We could even move the bounce code into the ball's update method to simplify this class further. This is a design decision. You must decide whether the ball should be aware of the game screen boundaries or not. You could also simply pass them as parameters into the bounce method. In developing your ball class, you might have found it annoying to have an attribute to represent the ball's position, and then to construct a method to get that position, and yet another method to set that position. C# has created an alternative mechanism to help alleviate the annoyance of creating accessors and mutators for attributes called properties. Properties are shortcuts for protecting your attributes. They reduce development effort, are easier to use, and still provide the same protection mechanisms that mutators provide, but C# is the only C-style language that supports these. In this first example on the right, we see the simplest version. An attribute called sprite batch that is publicly accessible and has a get and a set. This property shows how the attribute, accessor, and mutator can be combined into a single structure to simplify code. Since it is marked public, any class can look at or change the sprite batch whenever it wants to with no limitations. In our second example, we see what we refer to as an encapsulated field, which means there is still a private attribute, but we also implement a property with a similar name to provide easy access outside of the class. The get component returns the current texture, and the set component changes the texture to a new value. The keyword value is built into C# and is a shortcut for the new value of the property. It can only be used with properties. Next, we have the position property with a public get, but a private set. This implies that any other class can look at the position, but only the ball class can modify the position directly. Both get and set are optional, and you should carefully consider which you will need and how you can protect your object from arbitrary changes. Finally, we see a few examples from another class that uses these new properties. In this case, we might find these examples in the load content, update, or draw methods of Game 1. First, we set the ball's sprite batch to the Game 1 sprite batch. Next, we set the ball's texture to a loaded texture, and then we show how to test the ball's position against 0. Methods, as you know, are blocks of code that perform a specific task. The syntax for methods starts with a return type. This indicates the type of value that will be returned from the method. Void is used to indicate that no value will be returned. The method is then given a unique name, followed by parentheses, and an optional parameter list. Methods use parameters to indicate what type of values it needs to complete its task. By carefully crafting these parameters, you can make your methods more reusable. Arguments is the term for the value or variable we send to the method. If a method has void as its return type, then you should just call the method directly, passing it an argument for each parameter. However, if a method returns a value of a particular type, you must create a variable to store its return value. Otherwise, all of the work the method has done will be lost. In the example at the bottom, we see a method called average that returns an int as its result and accepts 3 ints as parameters. When we call average, we make sure to store its result in a variable called av so that we can use the result later, and we pass the numbers 3, 6, and 18 as arguments. But what if we want to return multiple values? We'll have to use something called reference parameters for that. But before we get to that, we need to talk about memory. To better understand how objects and value types are passed as parameters, we need to understand how memory is managed. Memory is divided into 2 segments in C# and most C-style languages, the stack and the heap. The stack is allocated sequentially in the order in which the code is executed. When a variable goes out of scope, it is deleted from the stack, freeing the memory it was using. However, objects are allocated on the heap, and the garbage collector manages this memory, deleting objects when they are no longer referenced. References are pieces of data that indicate the location of an object so that we can keep track of it. In your code, when you create a value type like an int, float, or double, you are allocating memory on the stack, and these variables get a small chunk of memory that is pretty much the same size as an int or as a multiple of an int, like a long is often the space of 2 ints. When you create an object, you are instead creating that object on the heap. This is why we use the keyword new to create an object. This indicates it is a different process from creating an int. In the case of this car object, we first create a reference to the car named C on the stack. We then link C to the new memory created when we say new card Ford Taurus. This creates a large chunk of memory on the heap with a small reference to that memory on the stack. The garbage collector then can quickly search the stack to see if there are any references to an object before deleting it. Generally, since objects are very large, we want to avoid copying them around our code whenever possible. This is why we use references to refer to an object instead of the object itself. So, when we pass a value type into a method, we don't care that we have to copy its value. So we call this passing by value, which means that the value is copied and any changes to that parameter are not reflected in the original value. In this code, we create an int called I, initialize it to 5, and then pass its value to the method value method. In this method, we refer to i's value as a. We attempt to change its value, but only change the copy of I, not the original I. Since objects are so large, when an object is passed as a parameter to a method, we only want to copy its reference, not the original object. We say that objects are passed by reference, which means that changing the object in a method changes it permanently. Here we see simple object, which is created in main, and then passed by reference to object method where its property A is changed to have the value 10. When we return to main, s.a now has the value 10, and if we attempt to access it, we will see this changed value. In this scenario, technically, we are passing the reference to our simple object by value, but since they both point to the same object, changing one means the other can see the changes. If we want to allow a method to change a value type, we have the option of passing it by reference using the ref keyword on both the parameter and the argument. Similarly to objects, instead of copying the arguments, references are constructed and changes to the parameters change the original arguments. In this example, in main, we create 2 ints I and j. We then pass them by reference as arguments to ref method. Ref method then changes I and j by changing its references to them, a and b respectively. These changes are permanent and main sees the updated I and j. So is there a time when you might pass an object by reference? Yes, you can. If you want the method to be able to create new memory for that object. The way objects are usually passed, their data can be changed, but which object their reference is pointing to cannot be changed. There may come a time when you need a method to create a new object for some reason, and the way to accomplish that is to pass the object by reference. In this example, we create a simple object in main, Then we pass its reference to the refObj method by reference. The method then creates a new simple object, moving the reference to point to this new object. The old object can then be deleted by the garbage collector. There's one more variation on parameters and arguments, and that is the out parameter. In this case, you may want to indicate that a method changes the value of its argument regardless of its incoming value. With reference parameters, the method may or may not change the argument's value, but with an out parameter, the method promises to change the value. This is particularly useful for methods that get input from the user. They can promise that a new value is returned, allowing other code to count on this method being successful. Here, we have the out method that promises to change its argument. In main, we create a string and pass it as an argument to out method, where it will get a value from the user. One of the drawbacks to allocating objects on the heap is that there is no guarantee when the garbage collector will run. So you might have some objects hanging around longer than they need to. However, there is a way around this. Instead of creating a class for objects that are performance critical, you could create them as a struct. For the most part, classes and structs are identical in almost every respect. They can have constructors and methods and can even use protection mechanisms. However, the big difference is that structs are allocated on the stack, meaning that their memory is destroyed as soon as they go out of scope. This could be a benefit for applications that create and destroy large amounts of memory frequently. One of the other differences is that structs cannot be null. You've probably already run into this with the vector2 object. It cannot have the value null. That is because it is a struct and not a class. Generally, it is better to use objects and classes, but once you have become an experienced developer or are building a game engine in C#, you may find that using structs over classes will become an essential issue.